Hi everyone, welcome to our video on derivatives and some business applications. So with business applications, there's often problems involving profit, revenue, and cost, or average cost as well. And so we have this list of vocabulary and formulas that are useful for us. And remember, if you haven't seen anything of this before, so these bottom three, whenever you see marginal, it means that we have an instantaneous rate of change to whatever the word is. So marginal cost, marginal revenue, marginal profit. So that means marginal cost is really the derivative of cost. Marginal revenue is the derivative of revenue. Marginal profit is the derivative of profit. Because when we say instantaneous rate of change, we know that that is instantly equivalent to a derivative. Okay, and then we also have these three formulas. Profit is revenue minus cost. Revenue is price times quantity. And then our average cost, or average anything, is just taking your whatever function is and dividing by x. Okay, or whatever variable that they're using. All right, so let's check this out. So in example 6, it says assume the demand equation for tickling Elmo is Q equals 10,000 minus 40p, where P is the price in dollars and Q is the quantity demanded. Find the marginal revenue for a production level of 3,000 units, or they might say it like this, or the demand is 3,000 units. Okay, so marginal revenue means we need to find the derivative of revenue, and then afterwards we'll need to plug in Q equals 3,000. So that's the demand. So the number of units is the demand. P would be the price in dollars, so we know it's not P. So this is Q equals 3,000, or this is also Q equals 3,000. Okay, so if they want marginal revenue, what we'll need to do is, okay, so and it might not be just instantly as I'm saying, it might take a couple more steps to get there, but marginal revenue means we do need the derivative of revenue. And then because we eventually will be plugging in Q, so we want the derivative of revenue with respect to Q. So that's the variable that I want. So eventually the derivative of revenue with respect to Q means we need R prime of Q. So we'll need R prime of Q like that. So they're using Q instead of X's, and they're also using P. So we have to make sure we're clear on which one they want. So derivative of revenue with respect to Q, and then afterwards, then plug Q equals 3,000 in. Okay, so we want this. All right, well, they didn't give us revenue, but they gave us this equation. Well, remember, so revenue, so let's first start with revenue. So I'm going to say number 1. So revenue, I'm going to put it in words, is price times quantity. Whoa, that's not how you spell price. Price times quantity. Okay, so I want it in Q. So notice they gave us this Q equation. So we do have two forms that we could write our revenue in. So if I were to write this out, so I'm gonna cross this one out in just a second. So I'm gonna use R equals the price, which we could just say is P, times the quantity, which is equal to 10,000. So this is showing. So I'm just subbing in that equation minus 40p. But this would be revenue with respect to P, with the price. Okay, so I don't want that. I would want that if they said, like, find the marginal revenue if the price is whatever. If they said the price is $7, then this is what we would want. Okay, but they're talking about quantity. So this equation, so this one would be good if they wanted something with price in it. Okay, so this is good if given P equals whatever. Okay, but we don't have that. So what we need to do is change this. Okay, so this one's okay and all. I guess we'll just leave it there. So, but this is not it for this problem. So keep that in mind. So if it's a different problem, we maybe would want this. Okay, so instead, what we'll need to do is we'll take the highlighted equation and we want to solve for P here. And then that way we could sub the P portion in for this expression. Solve for P. Okay, so if we have Q equals 10,000 minus 40P, to solve for P, we could subtract the 10,000. Okay, so I'd have Q minus 10,000 equals negative 40P, and then we could divide by the negative 40. Okay, and I'm going to divide every term like that by negative 40. And then that way we'll have our price. I'm just going to put it over to the side. So the first term I'm going to write as negative 1/40th Q. And then minus a negative would be plus. 10,000 divided by 40. Well, I'm going to use a calculator real quick for that just to be safe. That's the previous problem. Here's my scientific one. Okay, so 10,000 divided by 40 is 250. Okay, so it's just 250. Okay, so I have plus 250 is the P. Okay, so that's where, so again, this equation was okay, but it wasn't the one that we wanted in this scenario. I am going to use this equation again, though, and let's rewrite the price as this. Okay, so this is the price. The price is this. Okay, so that way we have, okay, so this one, again, was good if we had this case. What we really need, though, in this problem, so I'm just going to skip over it. So again, not needed for this one. I just want to keep it there to show, hey, maybe it's useful for other problems, but not on this one. So I'm going to write it as R. This time it will be R of Q equals the price, which is this expression in blue. So the negative 1/40th Q plus 250. Okay, so that was that portion. And then the quantity is just going to be Q. So the quantity is just Q like that. Okay, so there's all of our work. So sorry it's a little messy. But now that we have our revenue with respect to Q, so that was our main goal because of the way they gave us the units. Now we will eventually want to find the derivative. Well, to find the derivative, it'd be easiest to distribute this Q in. So our R of Q is negative 1/40th Q squared plus 250 Q. And then now I can find its derivative. Okay, so I'm going to put that up here. I'm going to kind of block that off. That was our scratch work to find P. There we go. Okay, so to do this derivative, I have R prime of Q is, okay, so the 2 would multiply the fraction here. So it would be negative 1/40th times 2, and then minus 1 from the power would be Q still. And then plus, this is linear, so it would be just plus 250. So our R prime of Q, once this simplifies, the 2 and the 40 would simplify to make a 20 in the denominator. So we have R prime of Q is negative 1/20th Q plus 250. There we go. So we found our derivative. Now our final step is to just plug Q equals 3,000 in. So now we've got, I needed a little more room, sorry. So I've got R prime of 3,000. So this is our final step though, equals negative 1/20th times 3,000 plus 250, which is equal to, okay, so I'm going to use my calculator at this point. Okay, so we've got, let me scroll so I can see it. There we go. Okay, so I've got negative 1 divided by 20, and then arrow, move it over, times 3,000, and then plus 250. And we get 100. Okay, so we have 100 is the marginal revenue. So it's $100 per unit is how that would be. And so what that means is, so marginal revenue is often the amounts made for selling one more item. So it's saying, like, if you were to sell one more item after 3,000, this is the expected revenue we would get, the $100 per that unit. Okay, anyway, so that's it. So I didn't give myself good room. Oh well. Hopefully it's all good still. All right. Well, that's if they give you this type of equation. So again, this might have been useful if they gave us price. Again, if they said find the marginal revenue for a price of $7, then this is what we would want to use. But often we have to take their equation and solve for it for whatever variable that is needed. Okay, so sometimes we have to change it. Okay, so be aware of that. Be careful with the revenue could be R of P or it could be R of Q. Chances are it's R of Q that we want, though. All right, and then moving on to number 2. So number 2 looks like I gave myself hopefully enough room. So suppose that the cost of producing Q units is given by C of Q equals 1/20th Q squared minus 300Q plus 500. Find the marginal profit when the demand is 3,000 units. All right, so for marginal profit, well, first, let's go ahead and set up our profit equation. And oops, I used X. Since our variable looks like it's Q that's important, let's use Q instead. So P of Q equals the revenue of Q minus the cost of Q. While we have those, the revenue of Q was in the previous step. Here it is. Right there. So let's sub it in. So P of Q is R of Q, which is the negative 1/40th Q squared plus 250Q, and then minus the cost, which is right here. Cost of Q is 1/20th Q squared minus 300Q plus 500. And remember to use parentheses. And the reason for it is because this negative will distribute. Okay, so now that I have my equation set up, so I have profit equals revenue minus cost. Now I want to simplify. So R of Q equals negative 1/40th Q squared plus 250Q. Distributing, I'd have negative 1/20th Q squared plus 300Q minus 500. Okay, so distributed, it looks like that. And then notice there's some like terms that can be combined. So these combine. And then our Q terms would combine. Okay, so we have P of Q is equal to, okay, the negative 1/40th minus 120. So they're the same sign. So it's kind of like adding, but make sure we still keep it negative at the end. We would have, so the common denominator looks like it'd be 2, so minus 2/40ths, or I need to multiply this by 2 to get the common denominator of 40, and it looks like my scratch work tells us it'd be negative 3/40ths, and then Q squared, and then the pinks add up to be 550, Q, and then our minus 500 still at the end. Okay, so there's our profit function. So we found the profit function. To find marginal profit, we just take the derivative of this. Okay, so I'm going to show that in blue. So I have P prime of Q. All right, so I have negative 3/40ths would get multiplied by the 2. And then we'd have Q minus 1 from the power would just be Q. And then this is just plus 550 left over. And then the derivative of constant is 0. Okay, so there's the derivative, and then let's simplify that last fraction. So P prime of Q is, well, the 2 and the 40 would divide. So 2 divides 40, and we would have 20 in the denominator. So we'd have negative 3/20ths Q plus 550. All right, so there's our marginal profit function. And then for our final step, let's plug the Q in. So they want Q again to be 3,000 into this right here. Notice I'm not plugging it in anywhere earlier. I want to get the full derivative first and then plug it in. Okay, so if we did plug it in earlier, we would just have a constant eventually, and then the derivative would be 0. So that wouldn't be correct. So that's why we want to wait till the very end to plug it in. All right, so we have P prime of 3,000 would be negative 3 over 20 times 3,000 plus 550. Okay, and then I'm going to use my calculator again at this point to help us along. So we've got negative 3 divided by 20, and then parentheses 3,000, parentheses, plus 550. And look at this. Okay, so this is a coincidence that this is the same 100. It just happens to work out that way. Okay, so don't assume this answer from above is the same as this answer right here. It just happened to work out that way. So this is P prime of 3,000 was $100 per unit. Okay, so that is the marginal profit. So that again means they would make, the profit would be $100 per unit at 300 units. So selling one more unit gains them a profit of $100 at that level. Okay, so that's it. So that's how we can break down these business problems. So they love these. So all of this bulleted here. So we didn't use the average cost in this problem, but I mean, they could use it. These are our most common ones that they use. So the revenue equals price times quantity, profit equals revenue minus cost, and then continuing to use them over and over again. Okay, well, anyway, I hope that helped. If you do have questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.